this idea of three principles: reduction of lead time, reduction of variation, and the quality of life. Along those lines, he presented something called the Toyota production system that was put on the board or presented at least 10 times through the class. What was the purpose of that? It didn't provide you the mathematical background, but what did it provide you? It provided you a way of thinking through what is wrong with the system. It gives you an insight into what the system is. So at the highest level of the Toyota production system, I have enhanced profitability. Okay, enhanced profitability comes from reduction of cost. What are the two types of costs we're talking about? Inventory or material cost and labor cost, which we've never addressed because we don't believe in that. When I looked at the inventory cost of reducing inventory cost, why would that be important? I'm connecting two different things now. That's important because if I can take my throughput, which is equal to WIP over cycle time, what he's telling me is I can actually reduce what? Inventory. But if I reduce inventory, I'm going to reduce my throughput. So that can't just be the answer. So I'm going to reduce my inventory. You see that? But then underneath the inventory, it comes and says, I've got a pull system. Underneath the pull system, it says I have to have a smooth production schedule. Underneath that, it says, in order to do that, I'm going to reduce my lead time. Oh, reduce my lead time. What is lead time? Lead time is another version of cycle time. So how do I reduce my cycle time? I asked myself the question, was this a single piece flow? The answer is no. Was this a balance line? The answer is no. So if I could have a single piece flow, this could automatically do what? Reduce the cycle time or reduce the lead time. If I could balance it, what would it do? And if I could do both of those things, what am I going to do? I'm going to be able to reduce my lead time. And if I reduce my lead time, what happens? I increase my throughput, but if I reduce my inventory at the same time, what do? I produce for my organization in a very cost-effective way. Question then becomes is, how do I create balance? And then we talked about machine layout and training, and we went down the list of things. And so you have to say, what are those things that I need to fix? In terms of single piece flow, what are the things that needed to be done to get me a single piece flow? And if I could not do a single piece flow, how would I put and implement a pull system? That's the initial set of thoughts that you have to have. How many of you had that? How many of you did not have that? Put your hand out there like this. Put your hand out there. Take the other hand. That's it. Bad, bad, bad. Or bad, bad woman. Right? This is the beginning of your thought process. Now, that is not sufficient because now you have to say inherently, one, what needs to be done, and then you have to bring in the math to be able to support exactly, and I'm leaving a huge area out, not explaining that to you at this moment, which could be started with the word V. Variation. I've not even talked about that. So that's what you need to do. I want you to comprehensively put it together. Is that okay? That's a start. Do not search through your notes. The searching of your notes tells you that I don't even have an inkling of what I'm doing. It is now your mindset. You're not driven by this, by the presentations. You're driven by what you think. You don't go and say, hey, your kids come to you and say, hey, daddy, mommy, can you help me with this? You don't go and say, well, what you start is at home, what do you do? Well, let me tell you what to do. You don't go back and say, let me look at a presentation and I'll come back to you in a minute or two. Right? Continue. You are, young man, are responsible for her.
I'm sorry.
Oh, jeez.
Oh.
Not dang.
Gets a what?
Isn't that last person that comes in the class?
Gets a what?
Gets an F in the class.
So then you don't need to worry about any of this if you're gonna fail anyways, right?
And I didn't say this, the class said that.
Oh, okay.
There's still a
I
couple
make-
people that saying something.
I'm sorry, I had a call from one. I had to take.
No, go ahead. We're doing an exercise here.
Oh, okay.
So he's gonna tell you what you need to do.
Yeah, so we have an hour.
What?
She doesn't believe she's
Explain
gonna
the
get
system
that.
engineer.
It is true.
See?
See, I think you would play along with us.
No, it was actually my idea.
You're the last person,
See, I think.
everybody, yeah. Somehow I became a liar today.
Yeah, through the whole process?
Yeah. Just today, I don't know.
Quality of life. Kind of explain that through the layers, like how you would explain it. So. What we
Lean
learn.
principle.
Yeah, what we learn.
Yes, young man.
That's what I was
And pulse this thing and all that stuff.
You can pull it, I mean, it's on there.
It's on, that's what I was doing. Thank you. I know you probably saw me look at it.
No.
I didn't, you can look at that, that's fine. I didn't.
The formulas.
Rather than looking through slides. Because I'm here to help do the process.
So everybody okay up to this point? So in essence, the key problems with the system is it's not balanced and it's not a single piece flow. Why is it not balanced?
Well, part of that was, there's only one person making bases, well, then you could have two different, I get personal line.
But they had to make double the amount of parts as the arm assembly.
So one was this issue of, I got one base, but I need a base for each short arm and long arm, so there's an imbalance here.
Right.
But further, I got three things going to one area, and there's an imbalance here.
So it's also physically moving the stations for easier flow.
At this moment, we're not talking about this. We're setting up, if I am going to a physician and I'm going to say, what's the problem? I say, do you have a temperature or you don't have a temperature? And that guides me to whether you have an infection or you don't have an infection. All right? We're at that moment. We don't have a single piece flow. Why?
Because we were running batches.
We're running batches. All right. So those are the problems. And the third problem could be possibly that because I have different people doing different things, that there may be a fair amount of variation. So I have not a single piece flow, not balanced, and a fair amount of variation possibly.
With yield variation in the delivery too.
That's right.
Because they're separate locations that took more time from each.
Correct. Those are your problems. That is very different in terms of thinking than saying, oh, there's a machine here and a machine here, we need to put it together. That is, I observe something, I interview something, and I relate exactly the same thing to somebody else. What you're doing is what? You're not relaying the same things, you're observing something, you translate that into your mind, and you're coming up with saying, these are my three areas that are problems. Then you say, why do these problems exist? Under the single piece flow, is it possible to have a single piece flow? What are the restraints in the single piece flow? Well, the times, in order to do that, I have to have something that is synchronized to have a one-piece flow. And putting two pieces of Lego together seems to me that the basic criteria is there. Setup. In order to do a single piece flow, I have to reduce the lot sizes, reduce the batch sizes. What restricts the batch sizes is what? The fact that I have setups. I have no setups in my Lego, so that I could easily go from 10 to 1. That's not the issue. The issue is the balance. How would I balance it? How do I balance things? I lay it out in the form of a cell, okay? And I lay it out in the fact that I have people that are multifunctional workers, and I standardize that process. Those are the key components that say, so can I standardize it? Yes, I can. Can I lay it out in the form of a cell? Yes, I can, right? And can I train people on putting different pieces of Lego together? The answer is yes, I can. So there is no restrictions on the balancing. So I have not balanced it, but there is no constraints on it. There were constraints that make it a lot more difficult. I want to reduce it to a single piece flow, but there's no constraints on it. I can do that. Tell me about variation. You have to tell me something about variation.
Bad.
First of all, how do you measure variation?
First, you have to define the process and define the cycle time and the time it takes for each step, and then the max and the min. Find your average, standard deviation, and your coefficient of variation.
Good. So you have to measure the variation of different things. But we'll talk a little later about what variation. So I want just you to be aware that is variation, but we'll talk about it a little differently. Okay? So there is that issue there. Now the question then becomes is, if I was writing your paper, I said, I better tell somebody what's the worst the system can be, what's the best the system can be, and where are we now? And we cover that. What defines the best and the worst?
It's like the critical width and the worst case scenario and best case.
Those are the measures. But what causes it? I mean, best case was when?
Oh, single piece balance line.
Single piece balance line. So, if I could create a single piece balance line, which seems to be there are no constraints, I am actually going to create the best case possible. Where are we now? If I have randomness on when things are coming, the number of pieces coming, when they are coming to a system, that creates for me the practical worst case. But if I artificially say, here's a whole bunch of stuff, that creates for me the worst case. In what case is it? So what you have now, is it the practical worst case or is it the worst case?
It's worse.
You have to kind of decide. If then you are designing it, do you have the capability to design close to the best case, or can you actually design the best case? You're going to actually design the best case. Focusing on that. Notice, this is expected of you in terms of the way you think. You cannot say, oh my God, what's the base? Oh my God, what's this? And say, oh, what am I going to do? You're not at that level now. You're at a level of what discussions we are creating. And you, when you go back to Y12, ORNL, or Rubbermaid, are going to be where I am guiding this discussion. Right? Okay. So put those thoughts together, and then we'll come back and I'll give you more insights.
He said that.
Shh. All right, so we got to the point where we're talking about what are the issues and what are the root causes of those issues. So what would your solution be? How would you define your solution? Your solution is what? So I know the problem is a single piece flow, and I know that I don't have a balance, and I don't need all this, but so when I am now, so now I've got to the point where I can understand where my problem is. So what is my solution? In order to reduce leak time, what is one of the fundamental blocks that I have to implement?
Balance line.
Take rid of waiting time, right?
What is the word? There's a tool, there's something out there that we discussed, I think in one class or two classes, called cell design. What does a cell design do? What is the fundamental basis of cell design? How many cells? Remember we went through the cell design? What is it? How many product families do we have? How many product families should we have? A long arm and a short arm. How should this cell be designed? It has to be balanced. Well, unfortunately for us, because of what we decided, everything is 2 pieces of Lego, so it should take about the same time. We put mechanisms in place called pull systems to say, hey, I got too much inventory, hold on, don't make anything. Remember that? If I got a piece here and somebody doesn't pick up the piece, I say, what? Don't make any. What is that called? That's called a Kanban system. So you cannot say, I put a piece of Lego, or I did this. You have to present this from a design perspective, because when you go into your own world, it is not Legos that you have to look at. You have to understand the fundamental principle. So the principle that you used to be able to design this was a cell design. Yes or no?
Yes.
So I had, in essence, what you did is a base, a short arm, a final assembler. Okay, I think this was the final assembler. I think you took quality out of it, if I remember correctly. And then you had shipping. And you did this for the short arm, and you did this for the long arm. Remember? You had a base, another, a long arm, you had the final assembly, you had shipping, and you shipped it out, and it shipped out every what? 10 seconds or 12 seconds or 6 seconds or something like that. And how did you design it? This is not a layout. The whole concepts that you use behind this were 2 key concepts of Lean, called a cell design and Kanban systems. That was your solution. That was your solution, right? So what was your solution? I am going to resolve this because I have no constraints. And I have no constraints. Because if you had constraints, your solutions would be to what? Resolve those constraints. In the Lego exercise, it was much easier because we artificially laid it out. No constraint, no constraint, no constraint. Therefore, can I balance something? Yes, I can. Can I do it in a one-piece flow? Yes, I can. But what is the mechanism that we use? Cell and Kanban system or a pull system. Notice the terminology difference. Was that your solution? Yes or no?
It was.
Yeah, it was. It was your solution.
We also reduced.
Yeah, we didn't drop quality, by the way, because we did keep them involved.
Which is okay.
Right.
Which is perfectly okay.
We ship perfect parts.
Yeah, they were bad. Okay.
Part of the cell design, we also reduced queue time by removing the unnecessary travel time.
But see, remember this whole concept of cell design does what?
Well, the poll system actually.
When we say, this is basically, we said, the definition of lead time. So initially when we were talking, I'm gonna reduce lead time, I could have even put down and say process time, move time, setup time, and wait time, right? Majority of your analysis on the existing analysis was where? You had a whole bunch of pieces within your system that never finished. What are they called?
Wait.
WIP. WIP is what? Waiting time. That was where your problem was. Your processing time was not a problem because it was two pieces. That was not your problem. The move time could have been a problem because we had a material handler initially that was doing all this stuff, so that could be a problem. Setup time was not a problem. So your two components that you were working on when looking at the design of the cell were these two, which was primarily the wait time. And how do I get rid of wait? When I balance the arrival of things with the service of things. Are we good?
High utilization.
What's that? We're gonna come to that. I mean, we're still haven't talked about, I'm kind of guiding you through the way I need you to think. Because if you cannot speak the language, you don't have the clarity of thought or cannot speak the language, you cannot go in to change your institution or mentor anybody. All you're gonna say is, I took a class. Well, if all you did was take a class, I believe, that I'm harsh, so you can say, oh, boo, 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 you know. You wasted Y12, ORNL, and Rubber Bait's money. That was harsh. But I didn't hear any boos. You could boo. It's okay. how do I design a cell? So the answer is a cell. So how do I design a cell? How many product families do I have? 2. What is the capacity of that cell? The capacity of that cell is driven by either people or machines, right? In this case, is it driven by people or machines? People, right? So it's easier to design it when it's people because you can shift responsibilities around, but if it's machine-based, then you either buy a new machine or do something with that particular piece of equipment. And I can determine the capacity of that cell. Remember, we talked about the capacity of the cell, so I can determine the capacity of a cell. And I can then determine the flow in that cell, and I can design that cell. So there is not just the fact that I have a cell, there's a logic on how to design a cell. How many cell types? How many of each cell type should we have? How should we design it so that we increase the capacity? And when it's a little bit more difficult than just the Lego, how many people do we need in there, and what are their responsibilities to be able to get that done? Those are the key kind of questions that we have. On a pull system is what? The ability for somebody to tell me that I need a part. And a Kanban system is a mechanism that controls the flow. What was the mechanism that you used? A Lego, I think, on a table, wasn't it?
Basically,
Or you can say, hey, stop. That could be a single tube. All right? Now, so I have the ability to think about what the problem is. I have the ability to think about my approach, and I have a general idea of my solution. But I need to understand that beyond that, the impact of variation. That's the hidden thing that nobody touches, right? Has anybody within your facilities that you've ever done a project came back and said, let me tell you the variation and how we control the variation? So does that mean that Y12 has no variation? Does ORNL not have any variation? Or Rubbermaid not have any variation? So how is it that I got an illness, but for the history, again, this is an exaggeration, right? From the history of that institution, there's not a single report that says, here is your illness, at least let me measure it. So what is variation and the impact of variation? Coefficient of variation, range, etc. I can measure it. And I need to measure it, and if it's low, I can ignore it. But if it's high, what do I have to do? I have to kind of control it, right? And I can control it 2 different ways. One strategy is that I reduce that variation. Or 2, if I, oh my God, in our institution, we just can't deal with variation. If that's the case, I can control the impact of variation by what? By a pull system. The pull system, or a Kanban system, buffers the impact of variation. Right? So, when I looked at this process, and I apologize for this, when I look at this process right here, let me take this. Well, we were obviously not supposed to do what we did. But that's tell me, when you look at now 2 different concepts, right? You have 2 different concepts. You have the rate at which things are flowing, and we have variation. How do you put it all together? Did we cover that? RACA. So I have arrival at each station, I have process at each station, and I have the output. The output impacts the input of the next phase. Is it the arrival or the variation? So if I am looking at variation, I just can't say, ooh, we got a whole bunch of variation. I have to kind of narrow down which variation I want to tackle, right? And how do I do that? If I had high utilization in a station, the variation that I want to control is what? Your variation in your processing. If I had a low utilization, I want to control the variation of how things are coming in. So I don't have to talk about this ambiguous variation. I can talk about very specific variation in this process. So if I'm looking at the station, and I made a mess of this. Okay. When I'm looking at this, at the base, what if I was to look at variation, what variation should I look at? Arrival or process? High utilization, low utilization. I think this was high utilization, wasn't it? Okay, so process. Short arm, process. Long arm, process. Final assembly, process. Quality was what? There was nothing done in the first 5 minutes of quality. Low utilization. What is the variation I want to look at? Arrival. What is the arrival variation based on? The mess that's created here. You see how you can use that particular concept. When I look at variation, I have to distinguish what variation. So if you came to me and said, let me tell you, yeah, variation is a problem, but this is the primary variation. Let me tell you, this primary variation of this arrival is based on the output of this. What is the output of this? It's because this is messed up. Why is this messed up? Because all of these are messed up. Now, I have means of being able to look at it, right? Fair enough? What is the impact of variation?
Increase cycle time.
Increased cycle time, increased WIP, increased buffering. In essence, you will have more capacity, you will hire more people than required, you will have more inventory, you will have more of everything so that you accommodate for this uncertainty. How much additional, and this is very bad, and if you don't want to answer it, don't. How much additional people, inventory, and resources do you have in your institution to conduct your mission at this time because of variation? Don't say it, don't say it. We could say the same thing about UT. So we're not saying any institution is anything. We're not saying Y12 is bad or Ornell is bad or Rubbermaid. We're saying we have an opportunity to focus on something that the rest of the world is not. And if we could reduce this amount of time at UT and this amount of resources at Y12 and this amount of resources at Ornell and so forth down the line, how many jobs do you think that we can bring back to the United States and still pay people $10 and $15 an hour? Is it the labor cost, or is the fact that I got $100 million of inventory of unutilized stuff that I need? We're losing a battle because we say, oh my God, we're going to pay, what is the minimum wage? $7.25. Or if it goes to $10, or it goes to $12, or it goes to $15, it makes no difference. Where is the majority of your cost? Is it the minimum? Is it the cost that you're paying to the minimum employee at Ornell? That's not your majority of a cost. So you to say that we become uncompetitive because we have that labor rate, where I have $100 million sitting every year of wasted resources, and we say, well, we can't compete, and therefore let's put our hands away. I believe this class, the funding that came out, and that's not including Oak Ridge, and that is not including Rubbermaid, but the funding allocated to this program is about $1 million a year. I believe something along those lines. For that $1 million, what are you taking back to your companies?